Hello everyone, so this video is going to focus on the threat for a snowstorm from Sunday through Monday night for portions of the Mid-Atlantic and southern New England and possibly into central New England depending on the track. This website, once again, is where I get all my forecast models from. Penn State eWall, it's a very good website to use. It was given to me by one of my friends, future friends at Stony Brook perhaps, so if you want to look at the forecast models, you can come to this website. Before I get to that, I just want to explain to you how complicated this forecast is, because the models are pretty different with what's going to happen. I'm looking at three different models. I have the Canadian model here, the CMC, and this the Canadian model, it brings it the furthest north out of the main three. It brings the storm just off the Jersey coast and the Delmarva, and it brings heavier snow into the northern Mid-Atlantic and southern New England. The European model is trending further south, so areas Mason-Dixon line and south will get hit there, and maybe into southern and central New Jersey. But if the European model comes through, I think southern New England would be spared. And then the GFS, the American model, is also, it's kind of trending along with the European, but it brings the snow shield into southern New England even though the storm is pretty far south. So, very complicated situation here. Now, if you guys remember the storm on March 2nd, or March 3rd, it was the first Monday in March, we had the storm track all the way up here 2 days before, and then 2 days later, it shifted all the way down here. The setup that was there for that storm is pretty much going to be the same for this storm. So let's go over that. You're going to have your low pressure coming in on Saturday. It's going to drag a cold front through into Sunday. So it's going to track like this, and it's going to go up into Canada. And then you're going to get a cold front that's going to come through. Let's scale it first and then rotate it. And this front is going to stall somewhere off the eastern seaboard here. It might be up here, it might be down here. We're not sure yet. Models are diverging on where that's going to be. So this cold front is going to stall somewhere. And as this low pressure moves up into Canada, it's gonna be, have the winds rotating around, and it's going to funnel in Arctic air down into here, and you're going to have high pressure set up. Somewhere around here, you're going to have high pressure set up. And that's going to also aid in the Arctic air mass that's coming down. So you're going to have cold air funneling down into New England and portions of the Mid-Atlantic and Midwest Sunday night through Monday. So it's going to be really cold Sunday night through Monday and possibly even into Tuesday. So this is all going to be, key. And also, not only this, but you're going to have two branches of the jet stream. You're going to have your northern branch somewhere up here, and then your southern branch somewhere down here. Now, if you remember with the March 2nd storm, what we missed was high pressure. This Arctic air mass was so strong that it kept pushing south, and it kept shoving the jet stream, the northern branch of the jet stream, further south, and your storm got suppressed, and it stayed down here. Is that possible with this storm? Of course it is. I think it's definitely possible, but there's also a possibility that this high pressure, this Arctic air mass isn't as strong, and it stays up here and allows the storm to come up north, and bam, you got a snowstorm, southern New England, northern Mid-Atlantic. Alright, so you know the setup now. Let's talk about the models. We will do, I guess we'll do the Canadian first because it's my favorite because I like snow, so here we go. Alright, so on Sunday, alright, so, actually no, that's too far, hold on. Alright, so here's what you have. So, take a look at, focus on this portion of the map here. You have a lot of energy on this wind map here. You have energy down here along the southern branch of the jet stream. You have energy up here along the northern branch of the jet stream. And what's going to happen throughout the day on Sunday is this is going to come south, and it's going to combine, these three pieces of energy are going to combine here. And then if you notice over here, you have your low from Saturday up here, and you're going to have high pressure set up over here. It's going to funnel in Arctic air. Your northern branch of the jet stream is right up here. Your southern branch of the jet stream is down here. There's your northern piece of energy. Here's your southern energy. Now watch what the Canadian model does. So I think that's too far. We were right here. All right. So watch what it does. All right, brings that south. See that? This moves south, and it combines. Whoops, sorry. It combines there. So now it goes from that to that. So it's digging south, and that's good if you want a big East Coast snowstorm, because what that means is it's going to be taking in Gulf moisture as it heads south. And if you look at your low pressure, high pressure map, you can see that you have storms forming here. Now your Arctic front from this is going to be stalling somewhere back along here. So it looks like it's going to be stalling further south. And since there's so much energy here, like it extends all the way up into here and then back down into here, you're going to have two areas of low pressure forming. Two separate areas of low pressure. And there's a difference between the European and the Canadian. The Canadian makes the first low stronger and the second low weaker, and the European is completely opposite. And so let's just take a look here. Alright, so that again continues to dig south, and then the northern part of this is going to actually shift northeast. So see, watch the difference here. So in the beginning here, this is where we were before. It continues to go south, and then watch. It shifts northeast. Look at that. Look at that. Look how quickly it shifts. See, what's going to happen is this northern branch of the jet stream up here is going to be guiding where this whole thing goes. Now, before, it's kind of shifting it south, but now, as this kind of moves out, this has negative tilt over here. This negative tilt is going to be directing the flow this way. So it's going to shift northeast. See that? So from that to that. This becomes negatively tilted, and it shifts the storm northeast out to sea here. So I still think there's a chance for this to come up the coast, but I'm not sure how far it's going to make it. Because if this comes too far south, it would suppress it. So now that we've explained the setup here, let's come back to our low map. So this is where the storm is forming, over here. Now, watch where it goes. It kind of goes east and then shifts to northeast. Now watch, this is your first low pressure system over here. And that's stronger than the secondary low back here. So this low is stronger. And then look at your precipitation map here. So you have all this heavy, this is all snow, this heavy snow over here, spreading into northern portions of the mid-Atlantic, southern New England, and even into central New England there. So this is the Canadian model, and this is the most aggressive of all the model solutions. Okay? So then, so you went from this to that, so then these go out to sea. Again, notice how there's this moves northeast. This comes off the coast further south, and that's going to shift northeast as well. And then they leave. Okay? So that's into Monday night. So if you look at your precipitation map, the onset of this is going to be Sunday night throughout the day on Monday, and your main threat, according to the Canadian model, is this area here. Okay? So that's your Canadian model. So the Canadian model, and again, look at the high pressure here, so that's your Arctic air mass. Northern branch of the jet stream is following up here. So that Arctic air is going to be coming in, it's going to get cold, and it would be cold enough for snow in that entire area there. That's the Canadian model. European. Alright, now here's your European. Alright, so when you come to Saturday, whoops, that's way too far. Alright, so here's Saturday, your southern branch of the jet stream's down here. Your northern branch is all the way up here, and there's energy embedded in the northern branch of the jet stream. You have your northern disturbance coming down. Your southern disturbance is down here. They're going to combine, like so. There's your storm forming. The European has this digging not as far south as the Canadian, so I think that's why this stays further south, one of the reasons. And also notice you have high pressure up here, and you have the low up here, so that's going to be funneling Arctic air, and this is going to aid in funneling in Arctic air as well. It brings the high over New England basically, so it keeps most of the area, most of this area dry. So now watch what happens with the wind map here. So that, again, look how strong that gets, because now you have energy coming down from here that's going to combine with that. So you have a lot of energy. So there we are. And again, like the Canadian, there's two systems of low pressure. This one comes a little bit farther north, so I think that there is, even with the European model solution, there's still a chance of seeing precipitation in southern New England, but I think it would be more on the order of light snow if the European is correct. It wouldn't be heavy. Now, the next slide here shifts that northeast as well. So your first low is now up, it goes northeast, and then your second low, the European makes stronger, and that would keep most of the precipitation down here. So, you notice you have high pressure up here, so the northern branch of the jet stream is further south. It's suppressing this down to the south, and then with the European solution, you do not get a heavy snowstorm, you get light snow in the north. The mid-Atlantic, you might get a period of heavy snow. My opinion on this is, if the storm comes further north, like the Canadian model is suggesting, there would be a bigger snowstorm. It would be pretty strong. It would be stronger, and there would be more snow. If this comes further south, I think it's going to be more suppressed, and there'll be a narrow band of heavy snow, but it won't be as extensive. It'll be a weaker storm, because it's going to have to fight cold, dry Arctic air as it heads east. So the European solution is south and suppressed. Canadian model is more favorable for a bigger snowstorm along the southern New England coast and northern portion of the Mid-Atlantic. The American model, it's kind of hard to interpret, but let's look at this here. Alright, so we're on Saturday. So you can see your energy coming down. Alright, so you have your northern piece of energy here, southern piece of energy here. They're going to combine like so. There's your storm forming in the south there, and again there's two lows. That shifts northeast now. See that? The northern part of it is shifting northeast. The southern part of it stays separate. Okay, now this actually looks a little different than before. Whoa, hold on a minute. That is different than before. Okay. That's a northward shift there. Well, actually, what I noticed is, remember I said there was two low pressure systems? Alright, so the GFS keeps the southern part of this low pressure to the south, but it brings the first low all the way up north now. That's a difference. It's still off the coast of North Carolina, but that is a northward shift in the American model that I did not see until just now. So we'll have to see that, then maybe there's a northward trend with this. Okay, so that comes north. You have your high pressure funneling in Arctic air. And notice that the northern shield of your precipitation just barely makes it into southern New England. So the American model, it's kind of similar to the European, except I think there would be a chance of moderate to heavy snow in this area here. The Canadian model is the furthest north. The GFS seems to be in between, and the European seems to be a little bit farther south. So that's what we're looking at right now. That's why this forecast is so complicated. I don't know what's going to happen yet. Your scenarios are the northern branch of the jet stream. That's another thing. Where is this going to be located? Okay, this is your northern branch of the jet stream right here. How far south does this come? How far south does the high pressure over here come? Okay, and then does all this energy actually come together perfectly? That's what you have to look at. Okay, so with that in mind, this video can't be longer than 15 minutes, so I came up with a threat area. It's kind of a combination of all three. Okay, so your threat is the orange is a lesser threat. I think the storm is going to be weaker out in the Midwest, but as it strengthens, you get into the red area. So again, southeastern Massachusetts, Connecticut, Rhode Island, central southern New York, New Jersey, southern Pennsylvania, southern Indiana, Ohio, and northern Kentucky, northern Virginia, Washington, D.C., Philly, New York City, Long Island, Boston, just south of Pittsburgh. Most of you guys are in the red area, so watch out. All right, in the next video I'll elaborate on this a little more.